Hello dear students, today we shall discuss some standard results and also we shall discuss some problems to verify CR equations for analytic functions, and also we shall see some problems of constructing the analytic function if the real part is given or imaginary part is given. So that now see that what are the learning objective of this session is to understand the derivation of some standard results like real part or imaginary part, a constant part is given. And also we shall construct of an analytic function if either real part or imaginary part is given or a difference of u minus v is given. So how do you construct that analytic function then? This is what our objective of this session. So now we shall see the standard results. First one, if suppose the function is analytic function such that the function is always real, show that f is constant. So what you have to do here, so what is given here? So a real part is given, so that wherein imaginary part is 0. Means what? If f of z is u plus iv, wherein u is given but v is 0. So that you can differentiate v with respect to x and y. This becomes a 0. This becomes 0. And suppose f is analytic. See that as given f is analytic and f of z is what happens as given like this. So that just you compare with the CR equations, suppose as function is analytic. So that here dou u by dou x equal to dou u by dou I. So that dou u by dou I is 0 and also dou u by dou x is 0. So then it becomes what here? U with respect to x is 0, u is with respect to y is 0. That means what? U is independent of x and y respectively. That means what? You can, if you integrate this one, u is also constant here. So either with respect to x and y. So that u is independent of x and y. Then ultimately u is constant. So that f is constant. So suppose as imaginary part is given. So that imaginary part is given, that then here real part is 0. So that you can differentiate with respect to x and y in u. So ultimately this becomes, these derivatives becomes 0. Since f is analytic, then CR equations just compare with these relations. So ultimately this relation becomes dou u by dou y is 0, dou v by dou I is 0 and dou v by dou x is 0. So ultimately this becomes v is independent of x and y here. So that means what? That is v is constant. So if it is v is constant, fz is also constant. So next standard result. Suppose the function is u plus iv is analytic in a domain D and magnitude or modulus of f of z is constant. Show that f of z must be a constant in D. Understand? That means you want to prove that an analytic function fz with the constant modulus is always constant. That means let fz be analytic and as given that modulus of f of z is constant, that is k, then where k is constant as we have. If supposed to be, we have two cases, one is k equal to 0, another one is k is not equal to 0. Suppose if k equal to 0, that this magnitude of f of z is also 0, means what? Modulus of f of z is 0. Ultimately this f of z is also 0. Then this is again it is also constant. And another case, let us suppose k is not equal to 0. then ultimately that modulus of f of z is also non-zero. So then we can have that is u plus iv, as we know that the magnitude of this becomes root of u square plus v square. So that means what? U square plus v square power half that. So as since fz is constant, ultimately this implies that u square plus v square is also k square, because since fz is constant. Then you can differentiate with respect to x in this relation. So that means 2u by dou x plus 2v by dou x partially. Then this is k is 0. That differentiate there. So that is 0. So since 2 is not equal to 0, then this relation is 0. And again you can take that is u square plus v square equal to k square. You can differentiate with respect to y in this relation, so that ultimately you get that is a u dou u by dou y plus v dou v by dou y, since 2 is non-zero. So by making use of CR equations, dou v by dou u by dou y is dou v by minus dou v by dou x, and also dou v by dou y equal to dou u by dou x. So that you can have that is relation here, so that by taking those two relations we have these two system of equations. Just we have these two relation system of equations, this differential equations. Just multiply equation 1 by u and multiply equation 1 by 2 v by 2, and adding these two we get this relation, and then ultimately this square plus this square whole square into u and into v. So ultimately uv and uv, that it is because since it is negative, so that ultimately it is both are cancelling each other, so that u square plus v square into dou u by dou x equal to 0. And this, since u square plus v square is constant k square, so that ultimately dou u by dou x equal to 0, so that dou u by dou x equal to 0, and since k is 0, so ultimately k is non-zero, so that this relation dou u by dou x is 0. And similarly you can take in these two relations, so just you multiply equation 1 by v and 2 by u, and subtracting these two we get a relation, again same relation, that is, but thing is that here dou u by dou x, here dou v by dou x, since k is non-zero, so that ultimately this is dou v by dou x is 0. So that both the dou u by dou x and dou v by dou x are 0. So that by making use of CR equations, ultimately this dou u by dou x, as you know that dou v by dou y, that this is also 0. And dou v by dou x equal to minus dou u by dou y, that is dou v by dou y equal to also 0. Hence u and v both are independent of x and y. Thus u and v are constants. Hence magnitude of this f of z is constant also. So that modulus of f of z is constant, then ultimately that fz is also constant. So then we shall see that what you do that for finding that is the derivative of that function, analytic function, and also you can verify some relations with this CR equations by verifying. Suppose in the given problem, if that is consider, you can see that point first you can take a u and v are the functions of x and y, and you can find differentiate x, y in u partially and v partially. So then you can find that is derivative using this relation, as you know that dou u by dou x plus I dou v by dou x, dou by dou x. So that suppose in the given problem u is given, you can use the CR equations, you can translate that u in terms of v also, that as you know that uy equal to minus vx, so that you can translate in this derivative in terms of u only. And suppose v is given, you can use again make use of CR equations, you can translate that is the this u also in terms of v, so that ultimately this u becomes ux becomes vy, And finally you can make use of that is the by Milnes-Thomson method, so that you can use that is the Milnes-Thomson method, just x replaced by z finally in the given derivative and y replaced by 0 in that relation. Finally you get a only that is function derivative as a function of z. Then you can integrate, you get an analytic function f of z. So suppose if it is the in the polar coordinates, so you consider the derivative this relation. That relation is e power minus I theta into ur plus ivr. So when u is given, then use the you can translate that v also in terms of u, that is use the CR equations in polar form. So Vr equal to minus 1 over r u theta, and you can ultimately this derivative in terms of only u there with respect to v that u dou u by dou theta there. And suppose v is given, again make use of that is the dou u by dou r in terms of dou u by dou theta into 1 by r, so that ultimately this derivative also in terms of v there. So that finally you can make use of the Milnes-Thomson method by replacing it r replaced by z and theta replaced by 0, so that ultimately that derivative as a function of z. So finally integrate, we get an analytic function f of z. So that now we shall see those examples. In this example, find the analytic function whose real part is given. This is the real part is given. Just you take that real part, differentiate with respect to x and y partially, and make use that is the derivative here. So take a derivative of that derivative relation ux plus I dx, and then you can make use of CR equations, so that you can translate that is the, because since u is given, so we have a relation, derivative relation only on u, so that you can take it, this conversion of Vx is minus Ui, and you can substitute those relations Ux and Ui, and that becomes, you can have a, this is the relation you have given becomes, so that ultimately finally you get a derivative there, and also then you can make use of Milnes-Thomson method by replacing x replaced by z and y replaced by 0, and you get a derivative in terms of z, integrate that, and simplification we get a f of z. And similarly, suppose this is the part, it is, if it is that is the whose imaginary part is given, so that it is in the polar form, so that you can differentiate with respect to r and theta in v, and take a relation of derivative that f dash z in terms of polar coordinates ur and vr, and also you can change that is the ur in terms of v theta, so that because since v is given, imaginary part is given only, so that substitute those v theta and vr, and finally you can simplify, that is using that is separating the real and imaginary parts, and do that here, so that we get that is minus 1 minus k square by z square. Just integrate with respect to z here, so that ultimately this relation becomes, so that analytic function. So that here, as I told you, imaginary part and real part here, so that finally we have a real part, we have got it there, so that real part, and also we have get it, because once we got it a imaginary part, so that we have this f of z integrate, after integrating we got this relations, and make use of exponential e power I theta and minus I theta relations, and separating real and imaginary part, in which real part is also we got it. And suppose u minus v is given, so that you can differentiate here also with respect to x and y here. We got it 1 and 2, and before that u minus v you can simplify by multiplication of these two terms, and then simplifications we got this relations, and differentiate x and y respectively in this relations x and y, and by making use of CR equations we have got it there ui becomes only because we can translate this become translate